there, kids?
We are recording.
Oh, okay. No, that's good. It was going to happen anyway.
Yeah, it's awesome.
Okay. Well, hello there, principals of algebra. You can just turn around and say hi to us if you want.
Don't.
Okay. So here we have, this is actually a consolidation from yesterday, but we're actually having to go back and do it because it is actually a great activity, and it's worthwhile. So here we go.
We just want to remind you what we talked about yesterday. We were looking at these magic number puzzles, and if you recall, we got all of these sets of directions, and from the directions we were supposed to do things to numbers over here, and we got to this point where we weren't actually writing numbers anymore. We were writing any number n, which we said was a variable, and so we tried to follow the directions that we were given. And so here it says multiply by 2, and that became 2n because n times 2 is 2n. We said you could also write that as 2 times n, but it's probably a little faster to write 2n.
Yeah, and definitely keep that the number or the coefficient out in front of that variable. Like that's just a good practice to get in. It'll get you out of a lot of hot water later when we start mixing negatives into the whole mix.
All right, so the next direction that we got was add 3, and we said yesterday you have to add 3 to the thing you got from the previous row. And so we have 2n, we're going to add 3 to it, and so we get 2n plus 3. And so what we're going to call is our magic number expression is that last line that we get, 2n plus 3. And an expression is just something that's mathy looking with some numbers, variables, addition and subtraction kind of stuff in it.
Yeah, so it's not like an equation you're trying to solve. Some people expressed some discomfort today because they kept asking, what's the answer? Like, what's the answer to 2n plus 3? It doesn't really have an answer. It's just something we can use to calculate a value. So don't try to be solving it. It didn't sound right. Don't try to solve it. Just realize that an expression doesn't necessarily have an answer. Yeah.
Now we have this second example. We're going to try to stretch your brain a little bit, and we're going to try to get away from these big tables that we've been looking at, like in example 1. And we're going to say something like subtract 4 from any number, then divide your answer by 3. And so in this case, what comes first? We think, well, first we're going to subtract 4, and then the second thing we do is divide your answer by 3. And these are really our first and second steps, but they're different from what's on example 1. And so for this, to subtract from any number, we do n minus 4, and that's taking away 4, subtracting 4. And then we have to divide the whole thing that we get by 3, and that's how we got the n minus 4 divided by 3 thing there.
Yeah, and again, I know it says the word answer there, but that's really the expression again. So the answer, quote-unquote answer you're looking for is just the magic number expression.
Yeah, this one you could say what you get. Divide what you get by 3, or something like that.
Okay, so I think we're ready. Let's do it.
Kalukale. All right, so we're supposed to follow the directions here and come up with our magic number expressions. So choose a number for any number n.
I choose n.
All right. So what do we do to this n?
Well, I see a multiply by -2. So, and again, I want to put the number out in front. So tell you what, let's write a -2, and let's put dot n because that's what I'm feeling right now. I'm feeling the dot.
Cool. There it is, -2 dot n. And so then we got to subtract 9, and we're going to subtract 9 from the whole thing we got on the previous row. So it's -2 dot n, and then we're going to take away 9 from that.
Wait, shouldn't that be -11n?
I'm thinking about it, and I remember this thing that you said yesterday about like terms, and these aren't like terms because one has an n on it and one doesn't. So you got to keep them separate.
Oh, okay. So so I can't take 9 away from n because 9 doesn't have any n's.
That's right.
Okay. So we'll tell you what. Let's clean it up for the magic number expression. I think we can probably now remove that dot and just keep it a little cleaner. So let's write -2n minus 9. Because they're not like terms, there's no combining. I think that's pretty much all we can do. What do you say?
Awesome. I like it.
Okay.
All right. Let's try another one. Should we pause for a moment to let them try it out?
Yeah, certainly. Certainly they can do it.
Maybe you should just pause the video for a second and try it.
Hey, media.
Oh. And we're back.
Okay.
So are we feeling n again?
You know, especially because I'm looking up there in that second column and it says for any number n, it's almost like they're telling us to use n. So I think we probably could have chosen anything. I mean, we could have chosen x or a y, or a z or a smiley face or whatever. But you know, they're saying choose n, so let's not get crazy. Let's just keep it in.
Cool. So we have n, and it says to subtract 7. So I'm going to take n and take away 7. N minus 7. Does that look right to you?
It looks good. I'm kind of looking ahead. I'll be honest. I'm kind of working ahead on this one.
Mm-hmm.
And can you do me a favor and put parentheses around the n-7? And if you're wondering why I did that, if you look at the next step, we're trying to divide by 5. And I know that if I'm dividing by 5, this doesn't mean just the n or just the -7. It's the entire thing I had before, the entire expression I had before. So I'm trying to group them using a grouping symbol. Parentheses are the most natural for me. So could you write the n-7 parentheses, small like that, and let's use a horizontal line, a bar, like a fraction bar, and then let's put 5 below it. And that's how I'll show that I'm multiplying the entire n-7 by 5.
Cool. Yeah, and those parentheses help me out too because I look at it and I know I got to do parentheses first. And so that says in this problem that we've written here that you have to take away 7 and then divide by 5, which I like a lot because that's the order in the steps that we got. Super fun fact, I learned that crazy bar is called a vinculum.
Vinculum.
Yeah, crazy Latin word for that. So,
okay.
Yeah. So are we ready for our magic number expression?
Yeah, let's do it.
Cool.
But wait, that looks pretty much the same.
Yeah, which is what it should be, right?
Well, you're basically saying we can't combine anything, so I think you're right. Like, we had this n-7 on top, 5 on bottom. I think we're good.
Cool.
Okay.
And you may see this written as n-7 just over 5 sometimes because this bar is also a grouping symbol for a lot of folks. And so this bar says do the stuff on top, then stuff on bottom, then divide.
The vinculum.
The vinculum.
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 Okay. Cool.
Yeah.
So we can keep the parentheses or drop them. It seems like there's not a difference either way.
Yeah. Whatever you're most comfortable with right now, I think is probably good. All right. So now we're supposed to do it sort of like example 2 up here, where we're just given kind of a little sentence and we're supposed to decide what the magic number expression should be. So let's get into it.
Okay. Am I up? Is this me?
Yeah, you're up.
Okay. Leading off. So multiply a number by 2 and then add 4. Now, does this tell us what to use for a number?
No, it doesn't.
Okay, let's get crazy. I'm going to choose the number to be x.
Okay, I've got my number.
Okay, so we're going to multiply that by 2. So we need to have like a dot 2 or just a 2 by the x as a coefficient. So can we write that 2 in front? Let's not use a dot. Let's write 2. Okay. Because I know with no symbol that still means multiplication, and let's put a +4 at the end.
Awesome.
Okay. Now I'm certain you guys paused the video before we went through that example. If not, that's a great thing to do before any of these examples. Like pause the video, then try it yourself, and then kind of watch us do it to make sure you're doing it right.
Yes.
As you should be doing with your homework.
Yeah, this is a good opportunity to pause right here before we zoom out and try this next one. All right, so any number again. We used x last time, so can we use m this time just for fun?
Love it.
Yeah.
My name is Mike. That'll be good.
Yeah. All right, so it says add 4 to any number, then multiply your answer by 2. And so add 4 to any number. I've got m. I'm going to add 4, so I think it looks like that. And then it says multiply your answer by 2, so I'm going to multiply by 2.
Okay. So you're certain of that answer?
I'm thinking about it. I mean, I did exactly what it said. It says 4 to any number, then multiply by 2, right?
I think you should use a lifeline.
What?
You make an old joke.
I'm asking for it.
Okay.
Hit me, Regis.
So here's what I'm thinking. So you have to add 4 to a number, and you get a result. And then you have to take that result and multiply it by 2. Like that's the way the example showed. That's what we're talking about in class. Because that's like step 1 and then step 2. But if I look at your final answer, your final expression, to keep the joke going, by order of operations, you have to multiply 4 times 2 first. And that's not what your directions say. So I think we have to make an effort to group together the n+4.
So we need to add some parentheses to say do the +4 first, then multiply by 2.
Yeah, absolutely.
Okay. I see. So we should have some parentheses there. All right. Pause again. All right, so it says divide any number by 5 and add 6. You want to take this one?
Sure. Let's make the number this time. Let's make it n. We haven't used that in a while.
All right.
So n is our number. We have to divide any number by 5. So can we use the division symbol? Yeah, and then 5 below. And then we have to add 6. So I think there's probably a couple ways we can do this. Parentheses might be okay here to kind of group the division first. But I also know division happens before addition. So maybe yes, maybe no, but let's write a big +6 to the right. Either one is fine. I know the one thing I don't want to do though that I'm certain you'll never see in class is to write like the plus 6 higher than normal, so it looks like it's just adding to the end, even though it's not by the division bar, which I forgot what it's called, or too low, so it's like by the 5, where it looks like below the fraction bar.
Mm-hmm.
So definitely want to write it big and off to the side, parentheses or not.
All right, so add 6 to any number, then square your answer. Pause if you're not paused right now. So I'm going to use a smiley face this time. Is that all right with you?
Love it.
Okay, smiley face is my any number. So it says add 6 to any number. I'm going to add 6 to my smiley face, then square your answer. So it says square your answer, so I need to square what I got. I'm going to use your advice from before. I'm going to group this together to say we need to add 6 first, and then squaring, I think, looks like that, yeah?
Yep, that means times 2, doesn't it?
No, because if it's up there, if it's little like that, it actually means to square. So like 4 squared is not 8 because it's not 4 times 2. It's actually 4 times 4. So it's a much different thing. It's 16.
Ah, okay, so that means smiley face plus 6 in parentheses times another smiley face times 6.
Yeah, we can kind of maybe write it real small right here.
Okay, so maybe not the answer we're looking for, but that would be an acceptable way to write it too.
Mm-hmm.
Okay.
Okay. Ooh, this one looks more complicated.
Oh, and it's my turn, isn't it?
Mm-hmm.
Great. Let me read it first. Okay. So we need a starting number. Let's use y. I don't think we use that yet.
Mm-hmm.
I need to subtract 5 from it, so let's do a minus 5. And it says to divide my answer by the starting number, so let's go ahead and group those together. Let's add that horizontal bar, and then my starting number was y, so let's divide by y.
Cool.
Okay, I think we're good. I think it's a good answer.
Yeah, I'm thinking about something that Johnny kind of got us thinking about today, and I think Skylar sealed it up for us. I guess this would be yesterday I'm talking about now. So yesterday we looked at one where you divided like each of the parts, so maybe this is the same as like y over y minus 5 over y.
Okay. So like you're basically saying I'm taking y minus 5 on the top and dividing each part by y separately.
Yeah. And then I can think, well, y over y, that's a number divided by itself, so that's like 1. And so 5 minus y. And so if you're feeling extra super cool about this one, you could get all the way down here to 1 minus 5y, but this is super okay as well.
Yeah. So like the answer on the right, that might be a little preview, right?
Mm-hmm.
Maybe a little preview of where we're going. So if you have a good sense of how to get there, like that is like the super happy fun kind of answer, I think.
Yeah, yeah. Okay, I think that's all we have for you for this little video. What we need you to do at this point is check in with Mr. Bostwick or Mr. Collins because they're going to give you a little quiz.
Oh yeah.
And then they're going to set you on your way towards something else.
Yep. So definitely invite you to go back over this work, maybe watch it again, like you have time to watch it a second time if you need to. And again, pause it, try it again, try some examples.
Mm-hmm. You can
Work
even
hard.
use different paper the second time, which I'm just writing to narrate myself.
Sure. No, I love it. It's almost like watching one of those lyric videos.
Mm-hmm.
But want to point something out, since you can use your quiz, or I'm sorry, you can use your notes on tests and quizzes. If you were to watch it a second time and use different paper, if that paper was, say, part of your notebook, you would have some really wonderful examples to study with later. I'm thinking.
Man, that's brilliant.
Yeah, just different thought.
Seems like you're a teacher.
At least 2 out of 5 days. I try to keep it light. So. All right. Thank you, guys.